In this video, we will look at the circumference and arc length of circles. And our objectives today are to use the formula for circumference, to use arc lengths to find angle measures, and to use circumference to find the distance traveled. We're going to start with vocabulary, and the first word that we'll be looking at today is circumference. Circumference is the distance around a circle. To determine the circumference of a circle, one thing that I could do is actually take a tape measure and measure all the way around it. And that would give me the distance around that circle. The next word we'll look at is diameter. The diameter is the distance across the widest part of a circle. So in this diagram, QR, right there in red, is a diameter. So I'm going to go ahead and label that. Measuring right across the very widest part of the circle. The radius is half of a diameter, or the distance between, or the distance from the center to the circumference or the edge. So I'll switch colors here, and SP, marked here, would be a radius. So going from point P out to the edge, that would be a radius. Finally, we should define what a circle is. A circle is a set of points equally distant or equidistant from a center point. So when I look at the center point here, point P, all of these points along the outside, which I'm making a dot here, I'll use the highlighter. All of these points around the outside are equally distant from point P. In other words, if I measured any of these distances, any of these radii, they would all be the same. Okay, I'm going to clean up my diagram a little bit here. There we go. Okay, next we're going to label an arc length. An arc length is a portion of a circumference. So we saw that the circumference was all the way around, but what if we just want to do part of the circle, like from Q to S? This is called an arc length. And then what about the area? If we want to take just a portion of the area, so I'll draw, or I'll shade in. What I'm shading in yellow here that's called, oops. That what I shaded in, that was called a sector. So again, a sector is this area. That's a sector. We can think of it as a pie piece. Okay, next, what is pi? Pi is the ratio of the circumference to the diameter of the circle. And we can say C for circumference over D for diameter is equal to this magical number pi. Pi is a number, but it's a number that goes on forever. 3.14159, and on and on and on. So because it's this irrational number that goes on forever, we use a symbol. This is a Greek letter to represent it. And it's so special to us because circles are so such unique and special shapes. They give us the wheel, they give us everything that's round, which is a lot of things. So circles are really special. So it turns out that the circumference of a circle is equal to pi times the diameter. Or put another way, the circumference of a circle is equal to 2 times pi times the radius. So let's try using that formula to solve some examples. The first example says, find the circumference of a circle with a radius of 9. So because they gave me the radius, I'm going to use this second formula. Circumference equals 2 times pi times radius. Circumference equals 2 times 3.14. I can round that. There may also be a button on your calculator. So we'll look at that in a moment, and then times 9. So I'm going to go to Desmos. And I'll go to the scientific calculator. So if I were going to solve this on my scientific calculator, I would do 2 times pi. So let's see. Where do we find pi here? There's pi. And then times 9. So that's still rounded. It's rounded to this 6 here. If you didn't want to find the pi button, you could type 2 times 3.14 times 9. And you'll get a really close answer. See, we got 56.54, and then we also got 56.52. We can just round it to 56.5. So I'll go back to my notes. We get 56.5 centimeters. Okay, example number 2. Find the radius of a circle with a circumference of 12. So now they're telling us that the circumference is 12, and we want to know what the radius is. So I'm going to write the formula first. I'm going to plug in 12 for C. And now I need to figure out what R is. Don't forget that pi is just 3.14. And 2 times 3.14 is 6.28. So my last step here is to divide both sides by 6.28. So the radius is 1.9 centimeters. Okay, moving right along. Find the diameter of a circle with circumference 15 pi. Okay, let's talk about this circumference of 15 pi. This simply means 15 times pi. It means 15 times 3.14159, blah, blah, blah. A lot of times when we're working with circles, we leave things in terms of pi. In other words, we just write 15 pi instead of changing it to a decimal. And the reason for that is that if you get good at it, it makes things easier. So let me write the formula here. C equals 15D. I'm going to make a substitution. I know that the circumference is 15 pi. I'm going to plug that in for C. So I'm going to say 15 pi equals pi d. And maybe you can see here, 15 pi equals pi d. I can actually divide both sides by pi. And when I do that, I'm just left with 15. D equals 15. And I'm done. Another example. A tire measures 26 inches in diameter. Find the distance it travels in one rotation. Well, one rotation is the circumference of the circle. So really what this question is asking is it's asking for the circumference. So I'm given that the diameter is 26 inches, and they would like to know what the circumference is. So the circumference is pi times the diameter. So the circumference is pi times 26, or 26 pi. You could leave the answer like that, 26 pi inches. Or if this were something that you were going to measure, you would change it to a decimal. So you would do 26 times 3.14, put it in your trusty calculator, and you would get 81.6 inches. Okay, so again, what that is, that's one circumference, or one rotation. We know that one rotation is equal to 81.6 inches. Now the question is, how many rotations does it make in 100 feet? So the first thing I'm going to do is I'm going to change feet to inches. 100 feet, there's 12 inches in a foot. So 100 feet is 1,200 inches. So now the question is really, how many rotations does it make if it travels 1,200 inches? So in 1,200 inches, I know that one rotation, whoops, I messed that up. To put rotation on the top. I know that one rotation is equal to 81.6 inches. And I want you to notice that what I did was I set this up so that inches would cancel, and I'll end up with rotations. So what I'm going to do is I'm going to take 1,200 and I'm going to divide by 81.6. And when I do that, I get 14.7 rotations. Okay, last question in this series. How far does it travel if it makes 100 rotations? Well, I know that one rotation, again, is 81.6 inches. So 100 rotations, if I just multiply that by 81.6 inches per every one rotation, when I multiply that out, I get 8,160 inches. By the way, that's 680 feet. Okay, we've done a lot already. We have looked at the circumference, the diameter, the radius of a circle. When we've used the formulas, circumference equals pi times diameter and circumference equals 2 pi times radius. Let's do a few more examples. Example 5 asks us to find the perimeter of the track. So what I'd like you to notice is that the left side is kind of a half circle and the right side is kind of a half circle. And so together, if I put these two half circles together, I get a whole circle. It's a whole circle with a radius of 8. So the circumference of that circle I can find by using 2 pi r. So 2 times pi times 8, or 2 times 3.14 times 8, which is simply 50.3. Now this is called a composite shape. I'm not quite done yet. I have to add, I'm trying to find out how far I would go around the track. And I just figured out the curved pieces, but now I have to add these straight pieces, and each straight piece is 24. So I'm going to take 24 plus 24 plus 50.3. And again, the 24s are these straight pieces, and then I'm adding the 50.3. And that yields 98.3. Okay, let's try another one similar to that. Here I've got another composite shape. And with this composite shape, let me zoom in here. Part of it I know. I know that this is 10 millimeters. And I know that this side here is 20. And I know that this side here is 10 again. So figuring out that perimeter is easy. Remember, perimeter, I should probably review. Perimeter is the distance around. So I can see that the blue that I've drawn already is 40, 10 plus 20 plus 10. But I need to now find out this green. This is a half circle. And the radius of this half circle is half of 20. This radius is 10. So the circumference of the half circle is going to be half of 2 pi r. A whole circle would be 2 pi r. This is half a circle, so it's just half of 2 pi r, or pi r. And that would be 3.14 times 10, or 31.4. So my total distance around, so this is 31.4 here. So my total distance around is going to be 31.4 plus 10 plus 20 plus 10. And when I add that all together, I get 71.4. And my unit is millimeters. Okay, next, arc length. This is a portion of a circle here. We can imagine drawing in the rest of the circle. It's kind of a weird looking circle, but let's go with it. Let's say it's a quarter of a circle. This is 90 degrees. And I know that if I went all the way around, I'd have 360 degrees. So this is 1/4 of a circle. The entire circumference is 2 pi r, or 2 times 3.14 times 8, which is 50.2 or 50.3. But again, that's the distance all the way around. But I just want a quarter of it. I want this quarter. So a quarter of that would be 12.6. And that's in centimeters. Okay, one more. This is a portion of a circle. It's 30 degrees. And we know that a circle is 360 degrees. So 30 over 360 tells us that this is actually 1/12 of a circle. So in order to find the perimeter of the sector, first I'm going to find this arc length. And I'm going to do that by finding the entire circumference of a circle that would go all the way around. 2 pi r would be 2 times 3.14 times 5, which is 31.4. Then I'm going to get my arc length. So I need 1/12 of that. That gives me 2.62. I'm not quite done yet. The entire perimeter is going to be the 2.62. That's the arc length here. Plus, if I want to find the distance all the way around the pi, I have to add in the 5, and then there's another radius here that's 5. So when I add that all together, I end up with 12.62. Okay, I hope you feel you've had enough examples to start the assignment. It's on page 598. It's questions 3 through 9 and 14 through 16. You can find that in the book in the classroom or posted on Canvas as a PDF. Good luck.